Perfect, thank you.
Good.
So I'm Christoph, your host today, and I have Tobias with me. Good morning,
Hello,
Tobias.
Christoph.
So today it's our last episode for this year. We will talk again about our next generation firewalls, and today about routing and the packet flow. So maybe some information in advance about our value-added services. So within our Zyxel support campus, we offer configuration services. That means as a partner, you have a chance to get a voucher once per year, and we do some configuration service with you. This always goes together with a training. So while we are configuring your device, we will also explain you what we are doing and why we are doing this. And you can get more information about that on our support portal, support.zyxel.eu. And yeah, one more information about our additional services is about the SSO across all our 3 support platforms. This is the partner portal, the support campus, and the campus academy. And for all these 3 platforms, you can log in with one account. Yeah, you can find us on LinkedIn and on YouTube. Also, this TECHtalk episode will be uploaded to YouTube later after the session. And you can also find the recording and a copy of the slides in our academy at academy.zyxel.eu. So let's start with the topic, Toby. Today we're talking about routing and packets. This is the 3rd episode of the Firewall series.
Yes.
What do you have for us today?
Yeah, what we are talking about, we will first check the packet flow explorer. We try to understand traffic from incoming to outgoing. Next one, we will also check this more in detail. So in which module exactly the traffic will pass through. Very detailed, we will go through the policy routing module and show you some routing examples in a live demo. Yeah, we have a tips and tricks section. If you're not aware of some features, you may are after that. And we have the feedback and solution window.
Yeah, as always, we try to make our TECHtalk interactive. So once you have a question about what Toby is explaining, you feel free to raise them in the chat. We also will have a live demo on our lab, like every TECHtalk. So of course, we can, based on your questions, directly show it on the device, or collect this question for later TECHtalk and come back to you in the next TECHtalk with your questions.
Well, then let's start with the first slide. So important here is that you find the packet flow explorer under maintenance. So maintenance is icon number 4 in icon number 5, sorry, in the web GUI interface. And there is a packet flow explorer. And this will show you the routing flow in our firewall models. So it starts from a direct route, goes through some VPN rule, policy route, and different others. And we will look more detail box by box in the next slides. Also, in case of you have UTM features like sandboxing, IDP, we have a lot of them. All this UTM traffic is also going through this routing flow, but a little bit more detailed. And I will shock you a bit now, but this is how it looks. Just as an example that you see once how a packet will go through our firewall and which or how many different steps it have. Yeah. So it starts, for example, with ALG, SIP ALG, goes through some DNAT packet check. Then we have the complete prevention part of UTM features here, followed by source-NAT, maybe some statistic, adding bandwidth management, speed if set, and then the traffic is out.
So on this picture, you can very well see what the CPU of the device needs to work with and work on.
Exactly.
And this flow is applied on every packet that is flowing through the firewall. So,
yeah.
Wow.
So it's quite amazing here. Well, so let's focus on the more easier part, not on the UTM part. We have first direct routes, and direct routes means each interface which we created in our firewall will be listed in this table. So we see here we have a WAN 2, WAN 1 interface, the local interface, local host. We created a LAN 1 with an IP address and a VLAN 10 with another IP address. So this means we're going into the configuration, for example, configuration Ethernet interface, creating an interface, and it will automatically add as a direct route.
So every IP configuration that I do on my interface, is it a WAN interface or LAN or VLAN interface, is shown here. So I can see my subnets here that I have configured on the interface. And yeah, so this will be shown automatically after I've created
yes.
that, right? Okay.
And direct routes are important, needed to have the first traffic working. So it's for, that's a complete LAN or VLAN, for example, can interact with each other network and find their way also to the WAN interface.
So an explanation, for example, if my VLAN 10 wants to communicate with my LAN 1 interface, it will use a direct route. And here we can already see that if I want to go from 172.16.2 to the 16.1 subnet, it will go through this interface that is stated there.
Exactly.
Okay.
So we also have the first warning here is in case of you are configuring subnets by your own or create range objects in the web interface, you may have a bigger subnet like /16, and bigger subnets may include other subnets. So make sure if you plan your network that your IP subnet calculation is correctly. Otherwise, it could happen that the subnet you just created or the object already include, in this example, LAN 1 and VLAN 10. And then there's no way for our device to differentiate, okay, I send my traffic to this interface or this interface, and you will have some IP routing conflict.
But this is not only related to interfaces, right? Also, if you plan your VPN topology and connect to other sites or maybe even home offices, you also need to consider your subnets and if they are overlapping or not.
Yeah, so for interface creation, the device have some protection to give our customers a warning when there is an issue and when not. But there could be still, for example, SSL pool, L2TP pool, objects which are linked into this and which could conflict potentially.
Okay, nice.
So be carefully about this. And the second point is dynamic VPN. So in dynamic VPN, each VPN scenario, which is not static, will be listed down. So this could be a VPN client. This could be a remote access point, which is connected to Firewall. And all these VPNs will also have an automatic routing. So it's quite impressive that you first don't need to think about, do I need a route for my VPN? It's automatically.
So if I define, for example, in a site-to-site VPN scenario, my local and my remote policy, it will be shown here in this menu.
Exactly.
Okay.
And the next point is policy route. So we will discuss later about it and move to site-to-site VPN first. So for site-to-site VPN, we have here an example, build a tunnel between this firewall and a Nebula firewall. And we have two different networks. We have 172.16.1.0 and we have 172.16.3.0 network. And you see it's different. So the routing from source to destination can work successfully. And we need site-to-site VPN rules. We have firewall to Nebula or even static VPN, which could work. Now it could happen that the interface on the site is similar, for example. Let's say the Nebula site also have 172.16.1 network. So in this case, we can configure a feature is calling SNAT in VPN tunnel. Then we can change the routing here. If I give you a short demo, if we go to VPN and go into the Nebula tunnel, phase 2 VPN connection, then show advanced settings and scroll down. There's a separate inbound, outbound traffic NAT. And here we can also build a routing that the network, which is similar, can be still work on the site.
I think we also have an article in our support portal that describes this configuration process step by step. So if you're interested in how this works, if you have a subnet overlap in your VPN environment, check our knowledge base. We have an article that it describes this in detail.
Well, then the next 3 points, static dynamic route, one-to-one SNAT and default WAN trunk, we will do a bit quicker. So for static dynamic route, it's usually not a need. So each scenario you could also cover by using a policy route, which is more detailed because we can link other objects like user, timetables, and so on. But there are a few less scenarios, like if you have two firewalls after each other, or some specific DNS routing where you need a static route. For one-to-one SNAT, it's only needed in case of you have one-to-one NAT configured. The most scenarios of NAT are virtual server, so also this box will usually be empty. But in case of one-to-one NAT is need, you will also find this in Packet Flow Explorer.
Maybe some information already to our next tech talk here. So in January, we will have an additional tech talk in this firewall series, and we will talk about NAT and virtual servers and one-to-one NAT and all the scenarios and when to use what.
Yeah. And then we also have the default WAN trunk, which means each interface, which is in our external interface, which is in our firewall, will be listed as default WAN trunk. So we can also have a look here. It's under configuration interface trunk, and by default system WAN trunk is selected here. So this means every available external interface which could be used for a WAN connection is in this list, and from here it will be grabbed. So it will be just make the routing available for each interface.
So the default option is that there is least load first, which is a kind of load balancer.
Exactly. Yeah, we have least load first, 50-50 traffic pass through. We have rate round robin, so you can say one WAN line is 80% of usage, the other one is 20%. And we have spillover. So spillover means if one WAN line is completely full, then it will swap to the second interface.
Maybe you quickly also explain the bandwidth that needs to be configured here, because it's quite important if you work with configurations like spillover.
Yeah, so we have this ingress and egress bandwidth, which is mainly download and upload. And for least load first, it's equal. But if you want to configure rate round robin or spillover, make sure to go first to the Ethernet tab on WAN section. And from here, you can configure the real available bandwidth on this DSL line or fiber line and make sure that the operation's working correctly.
Thank you.
Well, so let's move back to the slides. As last part in Packet Flow Explorer, we have main route. So main route show, again, quite similar to direct route, what is available, but also include potential overlappings. And it's also showing you if the gateway is set correctly. So you can use this page to analyze the routing, still check, okay, I set a gateway or I set the right gateway. And in case of there's any loop available, it will also show with the L character in flag that a loop is detected, and you can double check your topology.
A loop could, for example, be if I don't know, set up. So can you explain this? What?
Yeah, for example, you are putting WAN 1 and WAN 2 to the same CPE.
Okay.
Then you have already created a loop because both going to the same MAC address device, and you are not correctly linked to two CPEs, for example. Good. Then we will go to the policy route module, which is the most customizable module here. I have created two rules, which you can first see here, and we will later check also on the web interface and have a live demo. So the first rule says that the incoming interface LAN 1 with source any, so any means from 000 to 255, 255, 255, 255. Same in destination with the service ICMP type 8. This is a simple ping package. Go as next hop interface gateway 2, and the next hop info you see here now, WAN 1 or WAN 2. Don't be worried, the IPs are similar because of our test environment. The gateway is similar, but there's still two separate WAN IP addresses, so we can use this. Let's have a look on this for web interface.
Sure.
Go under configuration network routing, and from here we can see now our LAN 1 any service ping. It's even better visible. and the first next hop WAN1 going to 204 IP in the end, where our WAN2 is going to the 205 IP in the end.
Yeah, so it might be a bit confusing for a customer. So for this demo scenario, we have just used the second IP from our WAN IP pool. So in a real life scenario, you would never do this, I would say. So you rather have a, I don't know, backup DSL line or a 5G card or router connected as a second WAN interface, and of course then have a different IP subnet there. So this is just for our demo scenario.
Exactly. Yeah, and so the concept here, you can, for example, use WAN1 with a fiber line and WAN2 with a VDSL line, or you are using WAN1 with some high-speed line and WAN2 simply as a backup with an LTE router or 5G router. So you are flexible here how to configure it. The special config we have made here, if I go into rule 1, is that we have set up as option under show advanced settings, disable policy route automatically while interface link is down. This means as soon as we disconnect from our lab the WAN1 port, this policy route will not work and will be temporarily disabled. And why is this important? Because we define here that the complete traffic from LAN interface, if it's ping traffic, should always go through WAN1 interface. So if we not enable this option, this means because policy routing is working from top to bottom priority, our traffic will just not work. It will stuck, it will still redirect always to the first route here and send to the WAN1 interface and never reach the WAN2 interface.
What do I need to do if I don't have internet anymore on that line? So I think the scenario that the physical line is disconnected could be quite unusual for some customers. So is there also an option, some check that helps me to change the policy routes in case of the internet is down on the first line?
Sure. So you can in advance go to this option and not just select the first option, also select the second option for connectivity check. So even if your physical connection is not disconnected or Ethernet cable is broken, maybe just there is no traffic because the provider has some interruption. Then this connectivity check can help to also temporarily disable the policy rule and go to the backup rule number 2.
Thank you.
So I have now prepared a session, an SSH session to test this in real. So this session goes to my WAN2 IP, so it should stay stable, even the WAN2 will be disconnect. And you can do different commands on the SSH session. So for example, you can type in show interface all, and you see all your interfaces connected. So let's select the WAN1 interface now with a packet trace analyze to find our ping packet, our test package we will send from Firewall. So to do this, we have the command packet trace interface WAN1 IP proto for IP protocol and then ICMP. Now we are scanning each ping packet on the WAN1 interface. So we can move to the diagnostic page, and from here we have network tools available. We are choosing for the IP version 4 ping, and we are trying to ping the Google DNS server. Let's initiate the test, and let's look on our console. We can see echo request. We can see echo reply. So ping is working on the WAN1 interface.
And the network tool is behaving like a client now. It will choose the correct route automatically. Yeah,
so network tool will find automatic the right way based on direct route or policy route. You can also customize it in the advanced setting and select dedicated interfaces. For our test, we can still use the automatic way here. Now we prove first our ping is working. And we can also do different other checks here. We can, for example, say instead of the IP protocol, we just want to monitor our traffic to this IP address. So we are changing it to DST host for destination host 8888. And now we are repeating the test. we can still see, okay, we are requesting it, but we didn't see the reply.
Yeah, we see the outbound packets, but because we are just checking the destination host, we don't see the incoming
Exactly.
packets.
So for incoming, we need to scan the source host, for example. Then we can also see the reply. So if you want to do more of these SSH traffic analyzings, you may build up 2 SSH connection and have one open on source, one on destination, or you can do it based on the protocol.
Nice.
So let's move back to the IP Proto ICMP, and we are moving now, or we keep still WAN 1 active, so it's now listening to our ping packages, but we will disconnect the WAN 1 on the firewall.
Can you do one additional ping first that we can
Of course.
see it?
So we see now 4 ping packages.
Okay, and I will.
Now we are disconnecting the WAN 1 of the ATP 200. So now our WAN 1 interface is physically totally offline and broken. And we will now repeat the ping test. And we can see there is nothing more happen. So we cannot ping, it's just not working. Yeah. So what we do now is we are moving to the WAN 2 interface.
But we can still see in the GUI, in the web GUI, that the ping worked.
Yes.
So the ping still worked from there.
And we are repeating this test. And now we can see our ping result is going through the WAN 2 interface. So it moved from policy route 1 to policy route number 2.
Can you also show the status now in the routing configuration?
Sure. So let's move back to routing, and we can see here that policy route 1 now have a red LED. So red means it's just temporary disabled just because of the interface is physically not connected. Yeah. And now all traffic moved to our backup line.
Okay, cool.
So what we can do now, we can reconnect this interface.
Sure.
And now our routing table interface is reinitialized, and if it detects the correct way, then the routing will also show
now it's
activate. Yeah.
And there it will automatically fall back to the initial WAN run rule once it is connected again. Yeah. This might be important for customers who use a maybe 5G plan and need to pay, I don't know, 4 gigabytes. And of course, they don't want that their traffic then remains on the backup line.
Exactly. So based on region, 5G or LTE backup could be expensive. And to make sure your traffic go from WAN 2 back to WAN 1, the system is always scanning it. Yeah, based on the first option, if the link is back, or based on the second option for connectivity check, if the ping could work again.
So now this is active again. It goes again from top to down. So element 1 has a highest priority, and it should now go over WAN 1 again.
Yeah, so we can check it in network tool again. Go to ping IP version 4, 8888. And it'll be doing a packet trace on the WAN 1 interface. And test it. And it still takes now a bit time. And this is because of the up table. In the first scenario test, we have disabled a connection. We have a physical issue. So it was absolute mandatory to move to WAN 2. With you reconnect, both interfaces are available, which means there is no real routing table update in the backend. Only the regularly update will happen. And that takes around 5 minutes before the update is rolled back. Yeah? So now your interface for new traffic is still working, but for existing traffic, it is not. Yeah?
If you ping to a different address?
Yeah, let's have a test. It's still keeping, because my client, my source, is still the ATP. We are pinging from the ATP. If we now have a client like a laptop, we could make an ARP cache flush, and then this would work immediately. In this scenario now here, we have to wait approximately 5 minutes, and then this is recovered back to the WAN 1 line.
Okay, cool. Or if we just now, we could also force it with deactivating the second policy route, or pulling the cable.
Exactly, we can remove cable from WAN 2 or policy route, but usually it's just enough to wait a few minutes. Yeah.
Okay, nice.
Well, so let's move back to the slides. And we are here on a tips and tricks section. So first is unknown subnets via policy route. So let's move back to policy route here. We now show WAN interface routing, but we also can route VPN traffic.
Maybe you explain the complete scenario first. So why should we?
We have different scenarios. So let's say, for example, we're having an VPN client, an L2TP computer, which needs to have traffic to a remote VPN subnet. So
I connect
from client to firewall, from firewall site to site VPN to another site. Yeah.
Okay.
Then you need to build some routing, and this could be, for example, that you say here that the incoming is tunnel, and you are selecting your L2TP tunnel, and as destination you are setting the remote VPN tunnel subnet. And then you can select next hop VPN tunnel Nebula. So if you create this rule, we are now know that each traffic coming from our L2TP tool wants to reach a remote VPN subnet, needs to forward to VPN tunnel.
So with my remote access client or L2TP client, I can now access another site-to-site VPN that is behind my firewall.
Exactly.
Okay.
So this is always neat if the subnet is unknown to the routing table. So you can first verify in the packet flow explorer, is my subnet known here? So did my firewall somewhere have a routing to VPN? If not, it's need to create it. So we can, for example, establish the VPN tunnel here, and activate it.
I think the question was if there is a route from your remote access VPN subnet to the remote VPN subnet that you want to connect to.
Yeah. So let's assume that on this Nebula VPN tunnel site-to-site VPN we have here, there is now another subnet, 172.16.4 configured. This is unknown for the firewall. There is completely no route here, which is knowing the 4.x network. So what you can do is you can then create the policy route here and saying, okay, I go from my VPN client to destination 172.16.4, and please also send this through the Nebula VPN tunnel.
Okay.
Then it's known on the other side, okay, there is some network incoming, want to reach my LAN 2 subnet, for example, and I need to pass through the traffic back to the other side.
So on the other side, I would, of course, need to do the same configuration.
Yeah, so you would do this configuration on both sides with one incoming and one outgoing policy route.
Okay, so for this scenario, I would need in total 4 rules. So for each firewall, I would need one incoming and one outgoing.
Yes,
rule.
exactly. Well, so let's go to the next tip. It's the WAN backup concept, automatic disable policy route. We show this in the live demo. So whenever you are doing it, just disconnect it. I mean, we can check, are the 5 minutes over? Let's see. Let's double repeat the test. 888. Test. Now we see our VPN ping check 2 because we enable the VPN to Nebula, not yet. Yeah,
but so we can still see that there is some ICMP traffic in one.
So you see, this is, exactly. So we just enable the VPN tunnel, which is new traffic, and it will immediately go back to the WAN 1 interface.
Right.
Wow. The next tip would be traffic. So we could also prioritize traffic based on user. So in policy route, we have still the user module linking here. So in case of we have, for example, an admin team group, or we have users logged in by captive portal, we can say, okay, this complete school scenario, for example, that all my teachers will get the high-speed line, the fiber line, but all students will just get the lower performance line.
Okay.
So you can also differentiate this based on speed. And we have also multi-WAN IP support. That means we can support SNAT, source NAT for WAN IP. So this could happen if your provider gives you an WAN IP with some wider range, let's say of 8 or 10 IP addresses. Then you can assign one IP address per service. For example, mail server have a dedicated IP address, or VoIP server have a dedicated IP address.
So if we would now go back to your policy route configuration and change maybe just the source here in one of these rules.
Yeah.
So
this will be an enhancement then for WAN 1 to create an object, an address object, and saying, okay, this is my WAN IP number 5, and my WAN IP number 5 is the following. You create this object, and then you have this next hop. You still say WAN 1 because that's your primary, your main WAN line. But in SNAT, you are selecting then the WAN 4 or WAN 5 IP address, and this will then outgoing SNAT with the IP address you configured. So the services are clearly mapped to one IP address. This IP address can be linked to NAT module, firewall module, and so on.
This might be also interesting for the next tech talk, because there's, I think, still some confusion how to work with multiple WAN IPs that are assigned to one line. So most customers are just creating additional virtual WAN interfaces and assigning special IP addresses to these interfaces. Yes. But in the end, this is not needed because you're doing NAT in the end.
Exactly, yeah. So you don't need to go to interface Ethernet WAN 1 and create virtual interface here with the IP address. Yeah, you can completely skip this step. This is also limited to just a few IPs. Just use the routing module here, and you can go with all your IP addresses you have.
Yeah.
And then we have one more tip is the direct route option. I will just explain it to you. If you go to the advanced settings, there's an option, use IP version for policy route to override direct route. So if you enable this option, what will happen? If you go to Packet Flow Explorer again, this policy route box will move to the first position here.
Okay.
And the direct route will move to position number 3.
But this sounds a bit risky.
It's risky because all your standard interface routes, WAN interface routes, will be handled after policy route. And if you configure like me a route that says any to any, go to one interface, you lost your complete local intranet
so
network.
In this case, I would already have a match based on my source IP or destination IP, but I'm limiting it to the ICMP protocol. That means I would just allow ICMP for my LAN 1 interface, but because this is already matching, it will ignore every route that is coming afterwards, right?
Yeah, so you should not enable this feature, especially if you don't know exactly what is this doing. It's neat for some scenarios, like you have a firewall after a firewall, and you are just using the second firewall for UTM inspection, a complete isolated DM set zone, intranet zone. Then you may need it to have one policy route forward all traffic to the second device. But for a standard and normal scenario, please never enable this option here. Well, then we have in the previous tech talks the question of if GeoIP is a license-free feature. And yes, we can confirm it's license-free. And you can also combine GeoIP into the policy route module. So for example, we say that only the ping going to the Nordics, let's say Norway, should go through WAN 1 interface. So now we say everything which is a ping package with a destination server in Norway goes through WAN 1, and everything else goes through the WAN 2. So you can build whatever you want with source, destination, services, users, GeoIP. It's a complete flexible routing module here.
Okay, nice.
We have also updated 2 knowledge base articles. One is EKE version 2 with Nebula. We will show you in this article how EKE version 2 works with our VPN client with script export. We will also show up the limitations we have right now here and how to deal with that in the future. And we have released the SSL VPN client for macOS Ventura support, macOS 13.01. So this is also compatible. If you're not updated yet, then feel free to download the new client. And yeah, we are working every day in the knowledge base. We have so many agents which updating and creating new knowledge every day here. So feel free to visit this portal once in a week, twice in a week, and find out what's new. So let me see, we have...
or maybe additional to that, if you want to have some article created, of course, get in contact with our support team or write an email to academy@zaxel.eu. We will make sure that this article will be created then if it's missing.
Yeah. I see we have no outstanding questions for this topic. The other questions we will reply afterwards by email. Then I have a hint for you for our next tech talk. So if you already was in basic number 2 and 3 for firewall and policy route, NAT and port forwarding is like the final chapter, you could say, to combine these basic features. And this will happen on January 25th. So we will then show you a standard NAT and how to reach devices behind the firewall, how to reach a switch, how to reach an IP cam, how to debug my CCTV, for example. All of these kinds we will show in January Tech Talk.
Yep, and if you have missed our last episodes, you can still watch them on our academy, academy.zaxel.eu, or on our YouTube channel. I think we're at episode 25 or something already, so there's a lot of content to watch over the holidays. So
yeah. And that's a good start into the holidays. So I wish you already Merry Christmas, and we will see again in January, and next year we have a lot of new content for you. And yeah, I think.
Yeah, thank you all for joining us.
I
think this, last Tech Talk for this year, and also happy Christmas holidays from my side, and happy New Year. And we will talk again, January 25th.
Have a good time.
Thanks and bye.
We're Zaxel, and we're your networking ally.